Alright guys, now let's see on what will happen when you have outlier in your data. Alright, in terms of box plot, this is the box plot that we already discussed in the previous video, where you use this data and you have all of the Q quartiles, and we have the minimum and maximum number of 5 and 50. Right, then we just draw the box plot out of the 5 number summaries. Now let's see, when you consider outlier, right, in other words, when you are using this formula to consider the outlier, okay, usually we'll go for the my outlier first, then if there's any, we'll go for the extreme outlier formula. So when you calculate for the outliers using this formula, okay, this is what you get. Okay, the previously drawn data that of box plot that looks like this, which have a long tails on the right hand side here, which reach till 50, is actually not that far when you consider an outlier. This 50 is considered as outlier when you calculate it. Okay, so when you do the calculation, you'll see that actually those that exceed 36.5 should be considered as an outlier. So if you look at the raw data, okay, those that exceed 36.5, which is the upper fence for this data, should be considered outlier. So in this case, 50 here is obviously exceed 36.5, so it is an outlier. So an outlier cannot be used as part of the 5 number summary. It cannot become the minimum, it can't become a maximum. So what should we do with it? So we will exclude 50 as part of the 5 number summaries, and we will substitute it with the next nearest number, which is 22. Okay, so now 22 is our maximum number for in our box plot. So is 22 okay to be our maximum value? Yes, because it's not exceed 36.5, which is the mild outlier for our data. Right, so we have changed the maximum value. Instead of 50, we put 22. So we then just draw it back. As you can see, this is actually how it should look like when we considering outliers. So for outlier, which is a 50, we'll just denote it as a star. Okay, so that is on outliers. Alright, so thank you.